Hello, this is question 7 on your OCR paper 1 from June 2022. It's the AS paper, and you have to find the range of values of the constant m for which the simultaneous equations, this one which is linear and this one which is quadratic, have real solutions. So when we have to look for the solutions in simultaneous equations, and one is linear and one is quadratic, the best thing that we can do is to substitute the linear into the quadratic. We are going to make x or y the subject and substitute in the other one. In this case, I have the y the subject, so it's quite easy. I'm going to substitute the y by mx. So I'm going to have x squared, and instead of y, I'm going to write mx squared minus 6x minus 2mx plus 5 equal to 0. This mx squared is m squared x squared. So what I'm going to do is to put together the x squared, the x, to simplify that equation a bit. So I have 1 plus m squared multiplying the x squared, just collecting like terms, and then minus 6x minus 2mx. I can write 6 plus 2mx plus 5, something like that I can write, equal to 0. And this is a quadratic. We are going to study how many solutions we have. It's a real solutions, which means it could have 1 or 2. They don't say 2 specifically, so it means that it could be 1 or 2. That means the discriminant of this quadratic equation could be greater or equal than 0, because this one is 0, I have 1, when it's greater, I have 2. So let's going to find the discriminant. Discriminant is going to be b squared, the minus will go positive, so it's going to be just 6 plus 2m squared minus 4 times a, which is 1 plus m squared, times c, which is c. This must be greater or equal than 0. I'm going to expand brackets. So if I expand the first bracket, I have the first number squared, 2 times first times second, which is 24m, plus second squared, which is 4m squared, minus, I have 5 times 4 is 20, and when I expand this bracket, I have 20 minus 20m squared. That must be greater than 0. So I have collecting like terms, so 4m squared minus 20m squared minus 16m squared, then 24m, and then 36 minus 20 is positive 16. This must be greater or equal than 0. I'm going to change signs of everything. So I have this positive, I prefer to have that. That means the inequality is going to change sign, remember? So I'm going to rewrite this as 16m squared minus 24m minus 16, and this must be smaller than 0, smaller or equal than 0. It's a quadratic inequality. I think the best way of solving a quadratic inequality is graphically. So I'm going to represent that quadratic. To represent the quadratic, I'm going to find the roots. So 16 squared minus 24m minus 16 equal to 0. I can simplify dividing by 4. 4m squared minus 6m minus 4 equal to 0. And I can factorize. To factorize, I look for two numbers that multiply together, give me the product of these two, so minus 16, and added together give me minus 6, which are minus 8 and 2. Minus 8 and 2. So I can write this minus 6m and as minus 8 plus 2m. I'm going to separate that, and then I'm going to factorize the first two terms and the second two terms. So I have 4m multiplying m minus 2 plus, I'm going to get 2 outside m minus 2. These two are common, so I can factorize again and write this, and so m minus 2 multiplying 4m plus 2 equal to 0. And from here, I have my two roots. One root is m equal 2, and the other is minus 2/4, which is minus a half. That means my quadratic is doing something like this. This is minus a half. This is minus a half, and this is 2. And we are checking when this this quadratic, not this one is smaller or equal than 0, which means it's below the x-axis. So that's going to be between the -1/2 and the 2. Yeah, so that's my answer. My m must be smaller or greater than -1/2, greater or equal than -1/2, and smaller or equal than 2 to have two real solutions or one real solution. Give a geometrical interpretation of the solution in the case where m is 2. When m is 2, the quadratic is going to have a root. So the discriminant is going to be 0. If the discriminant is 0, I have one real solution. So when m is 2, discriminant is going to be 0. If the discriminant is 0, I have one real solution. Or you can consider that it's a double solution, which means between my quadratic, I think it's a circle. Is it a circle? Yeah, it's a circle. Between my quadratic and my line, I have one point of intersection only. That only can mean that is tangent. Yeah, so you don't even need to identify what type of line is, but if there is one solution, that means that the line is tangent to the quadratic. Or you can just say the line is tangent. If you are not very sure if it's a quadratic or a circle or whatever it is, you can say that the line is tangent, or you have just one point of intersection. Yeah, and that's all with this question.